Welcome, everybody, to the state of production machine learning in 2023. I am really excited to be talking about a very broad range of very relevant topics across the machine learning ecosystem. And we'll be able to delve into content that you will be able to revisit later on with the resources provided. You will find the slides in this link at the top right. So yeah, if you missed some of the talk, you'll be able to catch up on that on your own time. A bit about myself. So my name is Alejandro. I am director of technology at Zalando, a large tech company based in Europe, focusing mainly on e-commerce. I'm also scientific advisor at the Institute for Ethical AI and Machine Learning, a research center that contributes to policy and standards for the responsible development, deployment, and operation of machine learning systems. And I'm also governing council member at large at the ACM, where I contribute to policy as well as to strategic initiatives related to AI. And yeah, like I said, this talk is actually going to be referencing a lot of material, including several of my previous talks at previous PyData and other conferences. So you will see any references here. And because it's a very broad overview of the state of production machine learning, we will be covering a lot of content. Each of the slides is basically kind of maybe like a summary of an entire deep dive. So you'll be able to delve into that, as you find most interesting. So yeah, let's. Before we dive into, I also collected a couple of relevant talks that you may be interested about. So things across responsible AI, explainability, machine learning monitoring, metadata, as well as machine learning security, that you'll be able to dive into. So the key points that we'll be covering today include the motivations and challenges, the industry and domain trends, some technological trends, some organizational trends, and then we're going to be wrapping up. So let's dive first into the motivations and challenges. So one thing that has now become more or less consensus is that the life cycle of a machine learning model does not finish once you train it, right? Once you actually achieve that performance metric, whether it's accuracy, precision, recall, whatever it is, RMSE, whatever kind of like metric that you have, once you actually finish training your model, it doesn't finish there, right? The life cycle of the machine learning model actually begins once it's trained and once it's actually being used in production or in the particular use cases. And the interesting point about this is that there are a large number of considerations that have to be taken into account when we move into this different space, whether it is things like outliers, changes of the data itself, distributions, concept drift, the reproducibility components, et cetera, et cetera. So this is basically some of the hints of things that we're going to be delving into. But if we ask the question of why is production machine learning so challenging, I mean, there are a large kind of like laundry list of reasons, but some of the key areas that we can highlight here is different to, for example, traditional software, right? And traditional microservices, for example, is that there is a need for specialized hardware, right? So things like GPUs, TPUs, but also models that may require extra amount of compute or extra large amounts of memory to run and to be able to load them, right? Even like RAM memory. As part of this, there is also the complex data flows, right? Like different components, different pipelines that are being productionized, or different machine learning systems, as we'll be explaining later down the line, that actually have different steps where something that goes wrong could affect things, down the streams or even up the stream. There are considerations around the compliance, right? That brings, questions around things that you may have heard, like AI ethics, the challenges that we'll actually cover in a bit more depth in a bit, but also things like reproducibility, right? How do you make sure that whatever you ran last Tuesday is going to actually run again if you want to like debug it or you want to rerun it, right? So These are some of the higher level challenges, but it actually goes into the domain as well, right? Because when it comes to machine learning use cases, they tend to tackle particular areas that could also create potential challenges and potential risks that have to be taken into consideration. And we've seen, you probably have seen also areas like algorithmic bias, more traditional things like software outages that can affect machine learning systems in different ways, personal data in itself and the considerations around that when it comes to machine learning and AI, as well as the cybersecurity nuances that we'll also be delving into. But yeah, with this, we have to remember that the impact of a bad solution can be worse than no solution at all. And this is also why we care and why we should care about this in that sense. And that kind of adds another element to the mix, which of course, we weren't going to talk about the state of production machine learning without mentioning, LLMs or generative AI. But one thing that I do want to call out that will be relevant throughout the talk is that when it comes to the architectural patterns that are arising in the rise of LLMs, more specifically this agent chain architectures that we'll talk about later, they are a very good way of visualizing and getting an intuition of these production challenges of machine learning that goes beyond LLMs, right? And we will talk about some of the nuances there. Now, in terms of the roles, we also have to take into consideration that in order to tackle and understand what the nuances and requirements for production machine learning are the different responsibilities. So traditionally, we have the data scientists, the DevOps, the software engineering, but now we're seeing the rise and the standardization of the machine learning engineer, and also of the machine learning, of the MLOps engineer. And we'll reference a little bit more of that in the organizational trends. But then you have this new role, and it has also extended into the higher level around that intersection of the industry domain expertise and the policy expertise to bring in what are those AI/ML standards or best practices. So this is actually something that is important, because it is going from a best practice locally to a best practice that becomes more adopted. So that is one of the high levels of why should we care. Now, in terms of some of the industry trends that we see, is that we're starting to see, kind of the way that I like to think about it, 2016 and around those dates were the dates of the principles, where every organization was publishing a principle and a set of guidelines. However, as it progressed, then it moved from this sort of more higher level into more kind of like industry standards, regulatory frameworks. Right now, we're actually starting to see some frameworks within Europe to actually come to life for regulatory compliance. And we are also seeing the importance of going one level even deeper on the software libraries, right? How making sure that the underlying foundations are built in a way that actually are possible to align with those higher level principles. But then we also have to think about it that this very kind of like important responsible ethical questions cannot fall on the shoulder of a single data scientist or a single practitioner. And even though it is important to make sure that as an individual you can adopt best practices, making sure that you're having the right domain expertise, the competence in the field, the competence in the area, professional responsibility, it also requires different layers, including that team delivery process, right? Cross-functional skill sets within the area, key domain expertise, accountability structures, principle alignment. But then it also goes at a department or organizational level, where we're seeing that pattern of introducing, governing structures, human touch points throughout, AI systems, human in the loop requirements, and then also risk assessments, which we'll talk about in a bit. As part of that, we also see, as I mentioned, that policy is actually advancing at quite a fast pace. And whilst before, we often mention how regulation is playing catch up, we now see that it is the compliance that is now aiming to align with the regulation that is coming up. And it has been really interesting to see a lot of those frameworks that have been coming up across the ecosystem that have, in many areas, will be having some positive outcomes, introducing best practices. And in this pyramid that I was talking about, what is really interesting is this alignment between those higher level principles and also the underlying foundation, right? Whether it's the open source code or the actual software code that is developed for the particular use case. those principles are, useless if the foundation is not in place, right? And this is actually important because it brings us as practitioners as a critical component in these discussions and areas, right? So also some of high-level industry and domain trends. As I said, there's a couple of links, 1 hour plus sessions where you will be able to delve into a bit more detail if you're interested. So then diving into some of the technological trends, which I think, I guess in this session is a bit of the meat of the presentation. I want to just paint the picture, right? When it comes to machine learning frameworks and MLOps frameworks, we remember all how it started, right? Ultimately, you all were looking to, pull kind of one of the usual suspects for the machine learning frameworks. You were basically running a usual CFAR 10, and then you're able to kind of get some insights of your model, then you can apply kind of into a notebook and rinse and repeat as you're kind of honing down. Of course, this is oversimplifying it, but this is kind of how it started. But now, if we look at how it's going, we are kind of hit on the face with so much choice and so much set of tools, frameworks, technologies, areas, components that we could choose or we could not choose, right? And when it comes to kind of navigating this ecosystem, we have to ask ourselves, how as practitioners can we really navigate this effectively? One of the things that we have done at the Institute for Ethical AI, we published a resource that has been growing really, really fast, that has been aiming to collect some of actively maintained and used frameworks in the machine learning space across different areas. Explainability, privacy-preserving machine learning, AutoML, visualizations, optimization, etc., etc. So please do check it out. If you find that one is missing, please contribute it. That is the beauty of open source. But this has allowed us to actually delve into this question a little bit deeper. And we have found some resources that are pretty actionable and can be quite practical. Before diving into those resources, let's first take a step back and think about what do we talk about when we refer to the production machine learning ecosystem. And let's take what we could call an archetypal architectural blueprint, right? It's what could we reduce machine learning in production to? Of course, super simplified, because it's never going to be this simple. But let's think about it first in this sort of concept where you have training data, your artifacts, and then your inference data, right? You will want to actually perform what would be experimentation, right? Whether it's in a notebook or in a distributed workflow manager, hyperparameter tuning, training, evaluation, to use training data to create some models. You would then be able to want to actually make those models available, whether it's somebody clicking a button or having some sort of programmatic way of delivering that, right? Whether it's building the actual images or running tests, etc. You want to productionize your models, right? And this could be perhaps whether it's real time or whether it's batch, right? And once you have that, you want to also add some advanced monitoring or just some usual monitoring, right? And we're going to talk about that. As data goes through your models, as well as through your monitoring, you would be able to capture some of that data, which then you would be able to have a full cycle in the ideal world. And of course, throughout this, you have metadata flowing from end to end, right? However, when we ask the question of hey, well, what tools should we be adopting? One component that we have found that is very useful is this MyMLOps tool, which basically creates some kind of components that serve as the sort of archetypal areas where you can choose and swap different tooling, right? So here you would have your experiment tracking, experimentation, data versioning, code versioning, pipeline orchestration, model registry, serving, blah, blah, et cetera, et cetera. And you can pick and choose, what would work best for you, for your organization. And sometimes, when it's a very small kind of context, you actually probably do more harm than good bringing too much of a stack. But for organizations that are growing, this is what often has to be considered. Now, in terms of this sort of consideration, yes, we're thinking about the different components, but not only we see a shift in terms of the components that often are required to actually have a robust framework. And of course, when we're talking about this canonical stack, this can also be a single end-to-end provider, right? Like a single one which has end-to-end coverage. And there is a lot of kind of discussion of where it's best of breed versus kind of end-to-end. But ultimately, a lot of the times there is kind of context. but we're also moving into a situation where we're no longer productionizing a model, right? And this is what I was suggesting that the area of the LLMs actually visualizes quite well. But in the but in the more kind of like common large-scale machine learning applications, we see a situation where we're not productionizing a machine learning model, we're productionizing machine learning systems, right? And as part of this, you can actually see this is the embedding-based retrieval framework for Meta for actual search. You can see here that you have like an offline component that actually builds the embeddings, that has multi steps, even does quantization. You then have kind of like the online component, which does the ranking, the retrieval, the query processing. So here we're talking about, a multi-stage complex machine learning system. And when you think about your infrastructure, you have to think about also this in mind. So this is actually something that now brings new nuances that brings us from not just from machine learning model to machine learning system, but from model-centric to data-centric. And again, going back to this kind of like, pointer of the LLMs is that the reason why I keep repeating it is because it's often hard to actually verbalize in an intuitive way this machine learning system component. But with the introduction of kind of like this agent chain architectures, it's easier to think about it, right? Like an LLM interacting with other APIs, orchestrating kind of like interactions to be able to return a response requested by a user, right? So that is something that is allowing. It would allow you to kind of like build an intuition on what is meant by this point. Now, of course, there are considerations when it comes to thinking about the concept of models. And when it comes to a machine learning model, we often think about it in the same way that a model, a experimentation tracking system thinks about it, right? It thinks about it as the trained models. So let's think about, for example, we have a set of data with data instances A1 to AN, and we train a machine learning model, right? We train machine learning model A with a subset, right, of data. Now we train another machine learning model, and then another one until we train M machine learning models with different sets of data, right? So this is what we're used to, right? Actually being able to identify our machine learning models as artifacts and being able to store metadata about them, being able to think about them and reason about them this way. However, and multiple different model B, etc. But now when you put these things into production, you have a new concept, right? Let's say you deploy model A, M, in environment X, right? So here is an instantiation of your artifact. But you may also instantiate that, I'm calling it instantiation, deployment, into another environment Y. And then you deploy a pipeline that consists of this model and this model, right, in another environment. Right, so here, the metadata that is involved here, the considerations that are involved here, even though you indeed are referencing the same machine learning model, you have a completely different relationship and different conceptual way of thinking of your production ecosystem, right? And this introduces new considerations when thinking about your production machine learning systems, because it really brings the hardest of machine learning with the hardest of traditional software, at scale, distributed systems, microservices, etc. right? So, but together. And with that, you have, the whole host of considerations, right? One of them that we talked about was monitoring, right? So monitoring itself is something that we would then have to introduce to all of these instantiations, right? Like your model deployed over here, your model deployed over there. So it's important to think about the monitoring in the same way that you would have with microservices, right? Like your performance, right? CPU, RAM, etc. Whether there's a memory leak, you can identify it. But also machine learning specific nuances like statistical performance, what is the accuracy, precision, recall when it's in production, the nuances of the data, kind of architecture that you need in order to be able to capture actual labels, and explainability techniques and drill down on metrics. But then it's also going from monitoring into observability, right? This is in things like introducing alerting, automated SLOs, SLIs, service level objectives, and then also having automated way of productionizing things like progressive rollouts, canaries, etc. So, you can see here that there is kind of a trend towards intersecting from the best practices of distributed systems, large-scale software into the machine learning space. But the key thing is that as data science practitioners, we also want to not have to care about this, and we're going to talk about that a little bit more in the organizational side. Besides monitoring, we also have to consider security, right? And one thing that we have to know about security is in terms of trends, is that security is becoming now a big topic. And the reason why is because the area where you have to consider security is at every single stage of the machine learning pipeline, right? It's not only in the data cleansing, it's not only on the building of the model, it's not only on the deployment, it's at every stage of the machine learning lifecycle. And again, one of the things that we have been able to see, we published a resource called the MLSecOps Top 10, which is analogous to the OWASP Top 10. Now OWASP actually published their own top 10 for LLMs and for traditional machine learning. So I would recommend you to actually check it out, because even as practitioners, data science practitioners, machine learning practitioners, this gives you an intuition of what are some best practices that you can adopt, and also what are some best practices that can be rolled out, right? Things around poison pickles on loading model artifacts, poison data, access to the model, how that can lead into things like adversarial attacks, dependencies, bringing kind of like supply chain security into the play, etc., etc. So I do definitely recommend it, and we're running actually a machine learning security committee within the Linux Foundation that is exploring these areas, which has had some really interesting outcomes there. Okay, so then the final point, diving into some organizational trends. So we talked about the technology side, but now let's talk about the organization, right? Because as machine learning practitioners, you can't be a unicorn all the time, everywhere, right? You can't have a data scientist that is handling all the productionization, all of the training, all of the experimentation, and all of the domain, right? Especially as organizations grow, these are considerations to think about, and these are trends that we're seeing sort of like the industry consolidate towards. So one trend is basically moving from trying to take the software development lifecycle, what you would normally use in your SDLC, and copy paste it into your machine learning space. There is now a consensus that that shouldn't be the best approach, and then instead you should have a machine learning development lifecycle, which is more akin to a fit for context, right? And you would basically be able to bring in the most relevant areas for the different components, right? So that is one of the trends, is actually organizations bringing that standardization of process to be able to move their machine learning through their production line, let's call it. The second one is an interesting intersection between the MLOps and the data ops departments. So in the data ops, you would have the concepts of like data mesh, how organizations are introducing analytics to be able to take advantage of their data ecosystem from an analytical standpoint. But this is starting to intersect a lot into the machine learning production side, and how to bring both of those worlds together, how to bring in the requirements of data governance with also the requirements of machine learning governance within a single strategy, right? It's supposed to kind of like having a data strategy, a machine learning strategy, kind of like completely separate. So this is another interesting organizational trend. The third one is kind of this concept of metadata interoperability. We talked about the different sort of like heterogeneous systems that organizations often bring in. Not only often they bring in different like systems, but they may have different system for different units, right? And as part of this, what is important is to make sure that there's sort of like homogeneity or standardization in how metadata flows across, right? Such that irrespective of whether you have heterogeneous components, you can have homogeneous interfaces. And there's something that we're seeing at the different sort of like stages and areas of machine learning, because it's a need that organizations need to bring. Another concept organizationally is this mindset going from machine learning projects where you basically just deliver an outcome, deliver an answer, let's call it, right? You deliver an answer, moving into more of a mindset of products and bringing this product thinking into the machine learning space, going into this iterative agile means of actually delivering incremental value, productizing capabilities that then feed into themselves and iteratively allow stakeholders or domain or users to actually work at a higher level. As part of this, then also comes the organizational structure. And we are starting to see this, the concept that is often ubiquitous in the traditional software space around squads and like cross-functional squads coming into the machine learning space, where no longer you may have just data analysts and data scientists, but now you may have actually UX researchers, full stack engineers, machine learning researchers, MLOps engineers, acting kind of like in a very sort of like agile unit specific perspective. So that's another interesting one. Then actually mapping, of course, the technological outputs into the business outcomes, having different cadence for the different roadmaps around your iterative tooling development, your tools and products that can be reused across other teams, and then also the infrastructure that is used across the board, right? And this, even though it brings some initial kind of effort and some potential kind of like slowdown, it introduces standardization that eventually speeds up the outcome delivery. Now, in terms of the organizational shapes, one pattern that we see is that organizations tend to adopt too much too early in their journey, right? So if you just have a small team of data scientists, it's very different to if you and a few models. It's very different to having a larger group of data scientists with more models, and then a significantly larger number of data scientists with many machine learning engineers, right? So as part of going kind of like into that stack, you also have to consider how you grow as your requirements develop, right? In terms of automation, standardization, control, security, observability, reliability, but also in terms of the roles themselves. And the roles themselves that we see is, like I said, right, is if you have a small group of data scientists, they can operate by themselves. As they start churning out significantly more models and they start becoming busier by just operationalizing stuff, that's when it's relevant to start bringing machine learning engineers to be able to own that space, right? To be able to create reusable pipelines. Now, as this even grow further, right, this is when actually having multiple different sort of considerations in terms of delivery of applied science, that's when we start seeing this role of the MLOps engineer bringing kind of capabilities at the platform level. So this is a very interesting trend that we definitely do see. And you can see that this can grow and grow and grow, but these are some trends and some patterns that we see. So yeah, so those are some organizational patterns. Now, in terms of the wrap up, what I just want to also highlight is that when you're running around with a hammer, everything can look like a nail, right? And not everything can or should be solved with AI, right? There's a large number of problems in the world, and there's a very small number of solutions that should be kind of solving those specific problems. So that's something to think about as practitioners. And also the second thing, and just the thing that I want to kind of close in, is that we have to be aware that now critical infrastructure is increasingly dependent on machine learning systems. However, regardless of how many layers of software and hardware and ML abstraction there is, the impact will always be human, right? At an individual, at a societal level. So that means that it doesn't matter how many chatbots or LLMs you're introducing, there's going to be indeed some automation, but it's not going to be kind of like removing completely everything from the equation, and the impact is still human, right? So that's something to consider as well. And with that, I want to thank everybody. I hope you enjoyed this session on the state of production machine learning in 2023. Like I said, you can find the slides in this link. If you didn't manage to catch up a couple of concepts or areas, you'll be able to catch up at your own time, and you can then visit also the links provided. So with that, thank you very much.
Thank you so much, Alejandro. That was fantastic. I think we have time for a question or two from the audience, if anyone has any questions. Alejandro, would it be possible for you to share your slides in Discord?
I actually don't have the link. Would you be able to help me with that if I share the link with you?
Yeah, absolutely.
Oh, thank you so much. Let me send it over. There you go.
Thank you. I will post it on your behalf. And for those that would like to join the Discord, here is the invite link.
Thank you. And I can see some really nice comments. Thank you so much. Nice comments in the chat. Session is pure gold. Yeah, I'll take that one. Thank you. Yeah. Yeah, and then there's one on if we have some resources on organizational trends. Yeah, I mean, I'd love for there to be a bit more. I would say start with the slides and check the links, because there's enough links to keep you busy. And there were a couple of links on the organizational trends section. Yeah. I can see there's a quick question. Do we have time maybe for like a 1-minute answer?
Yeah, we'll keep it quick. I'll put this on stage. Our squads permanent teams are formed around projects.
Yeah, that's a great question. So I would recommend you to check out the research from Spotify, which basically like that's where kind of like concept of squads, tribes, etc. was presented. They tend to be temporary and separate to the organizational hierarchical structure, and they're set up for the particular process for the particular initiative. But yeah, I mean that explains it much better. And this is not now just a proposal to bring it into machine learning and how we've been seeing it quite effectively.